Hi guys, in this exercise we are asked to find the integral from 0 to pi over 2 cosine of h to the power 2n plus 1 dx. Please pause the video, give it a try and come back later to see the solution. Alright, let's denote our integral by in, okay? And let us introduce t, which is sine of x. This implies that dt equal cosine of x dx, okay? So what we have is that in equal the integral from 0 to pi over 2 cosine to the power of 2 of h to the power of n multiplied by cosine of x dx, okay? And now let's introduce t. We get the integral of 0 to 1, which is sine of pi over 2, it's 1. And this is 1 minus t squared, because remember that cosine square plus sine square is 1, right? So this is 1 minus t squared to the power of n, and this is dt. So this is our integral. And from here, we can try actually to use binomial formula by Newton, which is h plus y to the power of n, which is the sum nk h to the power of n minus k yk. And this formula will not work actually. Let's see why. This is gonna give us 0 to 1, the sum k equals 0 to n, nk minus t to the power of 2 k dt, right? And now we can change the sum and the integral, get the sum of k equals 0 to n, nk minus 1 to the power of k, the integral from 0 to 1, t squared t to the power of 2k dt. And this is very simple. This is 1 over 2k plus 1. So our integral actually is the sum of k equals 0 to n minus 1 to the power of k and k over 2k plus 1. And I don't know an exact formula for this sum, so that's why I said it doesn't work. Okay, is there a possibility to find the exact value of in? Actually, there is, and we can do that. How? Okay, let's remember that in, we find out it is the integral from 0 to 1, 1 minus t to the power of n dt, right? And now what we can do is try to find a recursive relationship between in and in minus 1. We can do that by using the integration by part, and this is the integral from 0 to 1, t prime 1 minus t squared to the power of n dt, okay? So this gives us t 1 minus t squared to the power of n 0 1 minus minus and minus is gonna give us plus to n the integral from 0 to 1 t squared 1 minus t squared to the power of n minus 1 dt, okay? This is 0. You have just to replace by 1 and 0. So we get our in is to n the integral from 0 1 t squared 1 minus t squared to the power of n minus 1 dt. Okay, how can we show in? An easy way is to use a simple trig, which is t squared plus 1 minus 1, okay? 1 minus t squared n minus 1 dt, okay? We can use the linearity here to n, the integral from 0 to 1 t squared minus 1 multiplied by 1 minus t squared to the power of n minus 1 and minus 1 plus to n the integral from 0 to 1 1 minus t squared to the power of n minus 1 dt. This is actually in minus 1, okay? And here, remember, this is 1 minus t squared. So if one multiplied by this one, we get 2n, the integral from 0 to 1, there is a negative sign here, 1 minus t squared to the power of n dt plus 2n, the integral of in minus 1. Okay, so here in, and this is in. So we can figure out that in 1 plus 2n equal to n in minus 1, right? So, and from here, you can say that this is 2n 1 plus 2n in minus 1. This is our recursive relationship. And from here, we can show immediately that in equal to n over 1 plus 2n, right? Multiply by 2n minus 1 over something, I don't know, over 1 plus 2n minus 1. And we can continue to do this until I is 0 or something, right? So we can show that we can compute this product. So we can use some very simple terms to find this product, okay? So this is in at the end. We can simplify if we want and get the final result, okay? After doing the math, I find that equals 2 to the power of n in factorial to the power squared over 2n plus 1 factorial. That's it. If you like the video, please give it a like, subscribe to my channel to help me grow. Thank you. Bye.